right, so we've been talking a lot about chemical reactions. We're going to kind of change gears a little bit and look at some of the math we have to do with different chemicals.
Okay.
So, you know from real life that there are certain things that's just easier to think of in groups. Like when you get eggs, do you get like 5 eggs ever?
5 eggs. I get them in a pack of 12.
You get them back to 12, and what do we call that pack of 12 eggs?
A dozen.
A dozen eggs. Does it matter what I have if I've got a dozen of it? What do I always have if I have a dozen?
12.
You always have 12. So a dozen is just a way of telling you that it's 12. If it's a group you're going to use all the time, it's easier to give it a name. So, we talk about eggs in dozens. We talk about...
What about a baker's dozen?
Yeah, you get a baker's dozen get weird. So you can talk about eggs in dozens. What else? Donuts. You get dozen donuts. A dozen cookies. It doesn't matter. They're just 12 of whatever you have. Do you think we could usefully think of atoms in dozens?
Well, if atoms are really, 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 really tiny and I have to have enough of them to actually see them, I don't think 12 is going to be big enough.
Yeah, 12 is probably not a big enough group. And actually, atoms are so tiny, you have to have really, really big groups of atoms. So...
A really big group of atoms. I don't know what to call it.
Yeah, this probably isn't something you've dealt with before, because it's such a big group of atoms. It has to be its own thing. It's going to be a mole of atoms.
A mole of atoms? I've heard of a mole before. You mean like the rodent?
Yeah, but if you've got that kind of mole, it's
or
something
this
different.
kind of mole.
It's something very different. But if we're talking about a mole, like as the name for a group of a certain number, a group that contains a mole of particles contains 6.02 times 10 to the 23rd of that particle.
That sounds like a really big number.
It is. So because it's times 10 to the 23rd, you take 602 and you put 21 more zeros after that.
Whoa.
So look at how big that is. It's huge. This is what kind of scale we have to talk about when we're talking about atoms, because they're so teeny tiny. All right. But no matter what we have a mole is always 6.02 times 10 to the 23rd. That doesn't change. It's like a dozen is always 12.
Okay.
All right.
I got that.
So a mole is so big. It takes some thinking about how big that really is. If we had, for instance, a mole of marshmallows, it would cover the entire United States to a depth of several miles.
Whoa, that's a lot of marshmallows.
That's a lot of marshmallows. It's a really big number, but atoms are really tiny. So this is what we're thinking about. All right, so we've talked about moles, and we've talked about that they're generally groups of atoms. Do you think there's any way to get between the two?
Moles, well, there must be.
There must be. So we're going to have to do some math. All right, so the math we're going to use for this is dimensional analysis.
Is that why we just got done doing that?
Yep, because actually you will find out most of the math we do for the rest of the year that's not straight algebra, and even most of the math you do in AP chemistry all the way through the end of the year can be done with dimensional analysis. So it's a really, really important skill to have.
You mean I'm going to have to do this again in physics?
Yep. So we have a new conversion factor that we can put into dimensional analysis, because we just said that 1 mole was always what?
1 mole is always going to be equal to Avogadro's number, which was 6.02 times 10 to the 23rd.
All right, and so you do need to know that 6.02 times 10 to the 23rd is also known as Avogadro's number. It's named after an Italian scientist. His first name is Amadeo, by the way. All right, so this is Avogadro's number. 1 mole is always 6.02 times 10 to the 23rd parts. And remember, if we need to, we can flip that. But we're going to start with it there for now. Things that can count as parts. What did we talk about in the first part of the video?
Parts, everything's made up of atoms, so that'd be a part.
So our smallest part we can have most of the time is atoms. Sometimes you actually have to deal with moles of electrons, but not so much in this class.
Ooh, that sounds dicey.
All right, so we've got atoms. If we put atoms together into groups, what do we have?
Molecules?
Molecules are acceptable.
Man, how about formula units?
Formula units, remember what we call what's kind of an atom of an ionic compound. And so if I take a formula unit and split it up, what do I have to split it up into?
Particles? No.
So we can do particles, and those will show up sometimes. We also have to remember.
Ooh, ions.
We may get asked about ions, but that's still just a part. All right, so don't freak out if it's one of these things, because it's always going to be 6.02 times 10 to the 23rd of whatever kind of particle we're looking at.
So pretty much the word parts is interchangeable with any of these things that go down this list. Okay.
Pretty much. All right. So we want to start with 5.69 times 10 to the 24th formula units to moles. And so if we look at our problem, it also tells us we've got barium nitrate. Do we think that matters quite yet?
I'm assuming that's a no.
Right, because no matter what we have, if we have a mole, it's 6.02 times 10 to the 23rd. So if we've got some group, that conversion still exists even if it's a random compound.
So it sounds like our conversions are going to be just a one-stepper for right now?
For right now.
Okay.
There'll be some more complicated ones here in a minute. All right, so we need to start like we did with our dimensional analysis with what we're given and what we want, right?
Mm-hmm.
So what are we given in this problem?
We're given 5.69 times 10 to the 24th formula units. And we want moles.
We want our moles, all right? So where do we always put what we're given?
At the very front.
At the very, very front. We're going to do 5.69 times 10 to the 24th. And remember, you can't leave off your units. It's going to be my formula units. And what do we always put under?
We're going to start with a 1.
We're going to start with a 1 down here. Remember, you don't have to write the 1, but a lot of times it can help us keep track of what we're doing. And again, if you don't like your tracks, you can just use times there, but this helps keep things neat. All right, so we've got our formula units. So if we've got formula units up here,
we need to put them down on the bottom.
we also have to have them on the bottom because we're going to want them to cancel out. All right? So, and what do we know about formula units and something else?
I know I can use a conversion factor there, and I can say that 1 mole is equal to 6.02 times 10 to the 23rd formula.
All right, so if we've got formula units down here,
I need to put 1 mole on top.
we need to put 1 mole on top. And how many formula units is 1 mole?
6.02 times 10 to the 23rd.
All right, so guys, I've got formula units up top, I've got formula units down bottom. What can I do with it?
Cancel out.
Cross them out. What does that leave me?
It leaves you with just moles, and that's what we're
And
looking for.
that's what we're looking for. So yeah, 1 step and we're good. Remember though, when we're putting this in the calculator, what do I need to use?
Parentheses?
Well, we could use parentheses, but that's actually more work than we needed to. We're a lot better off using our E key. And if you don't remember how to use your E key, talk to me about it. So we're going to do 5.69 E. And remember, E is times 10 to the. So it's 5.69 times 10 to the what?
To the power of the 24th.
To the 24th power. And then what are we going to do if a number's on the bottom?
Top to bottom, we divide.
We're going to divide. So divided by 6.02
E 23.
23. But this is why we use E and not just times, because if we forget to use our parentheses, we'd be multiplying by 10 to the 23rd at the end, and things get weird.
Right, so when I do that math, I get 9.45, and the number goes on from there.
All right, but remember, when in doubt, you should remember your significant figure rules, but actually in this case it works out the same way. When in doubt, 2 decimal places. So if we go to our 2 decimal places, that gets us
9.45, and there's a 1 behind the 5, but it leaves it just
so it's going to
5.
stay the same. And what are my units?
Moles.
Because that's the only thing that's left up here. All right. And yes, MOL is moles.
All right.
So now we're on to our next problem. And here we're trying to get the molecules that are in 3.04 times 10 to the negative third moles. So where do we start?
What we're given, and
So-
then what we want to find.
We need what we're given and what we want. What are we given?
We're given 3.04 times 10 to the negative third moles. And we want to find molecules.
We want to find molecules. And remember, molecules was just another way of saying what?
Parts.
Parts. All right. So where do we put what we're given?
At the very beginning on the top.
Very beginning on the top. Oops. is -3.
All right.
And this is molecules. And yeah, it's hard to abbreviate because otherwise we also have moles. We're going to make our tracks.
We're going to put a 1 on the bottom.
We're going to put a 1 on the bottom so we don't think we just left it off there. All right, so if I've got molecules up here, where else do I need?
I take them diagonally down.
And this is not molecules.
Ooh, it's moles.
Yep, you've got to pay very close attention.
My bad.
So this is actually moles, because it's different than the first one. So if we have moles here, what do we need on the bottom?
Moles.
Moles. And we're trying to get to...
We're trying to get 2 molecules.
We're trying to get 2 molecules, and what's our conversion factor between moles and parts?
So I can put 1 mole on the bottom, and then my parts is 6.02 times 10 to the 23rd. And it's going to be molecules.
Yep.
All right. So I'm using that E button again, right?
So we're going to do 3.04 E, what?
-3
-3, then what?
times.
Times, because they're next to each other. And then times our 6.02.
E.
Yep, E. Do not use times, your life will be more difficult than it needs to be.
23.
23.
All right. And when we do this, I get, if we're saying keep in the whole 2 decimal places, 1.83 times 10 to the 21st.
Times 10 to the 21st. And what are my units on that?
And my last remaining units that didn't cancel out are molecules.
Right, because we had moles, we get molecules left over. All right, but is that the last thing it tells us about?
It goes from a number 1 to a number 2, and then it just asks how many atoms of nitrogen. So is this where the formula, or where the name of the substance we're using might actually come into hand?
This is where we need to know what we have moles of. All right, so we just said that we had 1.83 times 10 to the 21st molecules of, what does our problem tell us we have molecules of?
Dinitrogen pentoxide.
Dinitrogen pentoxide. Remember, for covalent compounds, we use our prefixes to give us our numbers. We have N2O5. And so, we can actually use that as a new given.
And since we have molecules up top, we need molecules down below.
Right.
So we have 1 molecule of N2O5. And then it's asking how many atoms of nitrogen. So that's where I'd go back and look at the formula, and I see that it's got N2. So that's 2 atoms of nitrogen?
Yep, for every 1 molecule, we've got 2 atoms of nitrogen. And so I've got molecules on top and molecules on bottom. What can I do?
We just multiply times 2.
Right, so we're going to cancel out our molecules. That leaves us with atoms, which is what we're looking for.
And we get 3.66 times 10 to the 21st atoms of nitrogen.
So this is where it's very important that you actually put your formulas with your units. This part, it's not as important as we get onto other things like stoichiometry, which we'll get to later. It's really important because you're going to have molecules of one thing and molecules of something else, and you've got to know which molecules we're talking about.
That sounds intense.
All right, so now is a good time to try some problems on your own.